Okay, here's our next one, example 6. Fish is reeled in at a rate 1 foot, etc., 10 feet above the water. Let's fill in some of these measurements here, these dimensions. Okay, so reeled in at a rate of 1 foot per second from a point. So this is the point where it's being reeled in. It's into that point. So that would be 10. The height there would be 10 to the water. And it's reeled in at a rate of 1 foot per second. So that tells us that dx dt actually equals -1. It's reeled in, tells us it's shrinking. The length of that fish line is shrinking. So that value x is getting smaller. That's what that tells us. Okay, now we need a relationship. The title of this section is Related Rates. So we need some kind of a relationship that will give us an equation that when differentiated will relate the rates involved for the variables. Okay, so let's start out. What kind of a relationship do we have in here? We could say we want something that involves theta because it says the rate at which the angle is changing. So that would lead me to think we probably would start with something like sine of theta. And we know that that's going to be 10 over x. So here we have an implicitly defined function for theta. And to get what we want notice the rate at which the angle, we're interested in d theta dt. That's what we want. We can get that indirectly here if we just start differentiating. So let's go ahead and differentiate both sides of this equation. D dt, both sides, dt. Okay, so the left side will give us a cosine of theta, d theta dt. There it is. That's the thing that we need. And the right side, this is 10 over x. Remember, that's 10 times x to -1. So that becomes -10 x to -2 dx dt. Okay, and let's solve this for d theta dt. You'll have -10 dx dt over cosine theta, and then we have an x squared there. Okay, so we need a couple things here. Well, we have dx dt, we know it's a -1, so we have -1 times -1, that. And now we need x and we need theta. So we're gonna have to work around this. Over here, let's see. Let me just look at this triangle that we have here. We have a 10, and at the moment when there's 25 here, that fixes this triangle, fixes theta, and therefore it also, we see that x is 25, so this would be 25 squared down here. But we need the cosine of theta, so that means we have to actually find x here. I shouldn't call it x. Let me call it something else because I don't want it to have the same name as that other variable. So let's call this, I don't know, d. So let's get that number. Let's get the cosine. Let's get the d first, and then we'll get the cosine of theta. Now, there's a couple ways you could do this. You could calculate the d. D would be equal to 25 squared minus 10 squared. And once you have that, you can find that the cosine of theta would be equal to that number that we just had, 25 squared, which is 625 minus 100 over the 25. So if you just put that in your calculator, you'll get to a number here. All right, on the calculator, this tells us that theta is approximately, I'm not even going to give you that number. I'm just going to give you this number here, 23 point, we'll keep this as 578 degrees. Okay, so we got that number. Cosine of theta, there's theta, and this number, let me just, let's see, I got it. It's, let's see. Yeah, okay, so we've got theta, and cosine of theta, well, okay, so here's our finished product here. We really didn't need theta, but all you needed was this number here, which turned out to be about 0.9165. And I'm just using that in my quotient here. So I drag this down over here and slip those numbers in, and here's what I got for d theta dt. Okay, so that's the